Hello everyone, welcome to Out of Spec Testing. I'm Ryan. Today, I'm with the brand new 2025 Hyundai Ioniq 5. Huge shout out to Crossroads Hyundai for lending us this, but today we're going to be taking it on our 70 mile per hour range test. How much highway range does this new 2025 Ioniq 5 have? It does have a bigger battery and more rated range, but we're going to find out exactly what that means today. Let me tell you a little bit more about this 2025 Ioniq and about our testing procedures. This is the 2025 Hyundai Ioniq 5. It is looking very similar to the old one, however, it is technically refreshed. There are a lot of small updates, and I think a lot of them add up to something that's kind of nice. Whether it's worth upgrading from an old one, not entirely sure. That would be your decision, I suppose. Regardless, this vehicle is technically still under embargo, so I'm not allowed to talk about certain things such as driving characteristics, handling, all that kind of stuff. But I can tell you a lot about the features and tell you about objective facts and our objective testing. So this new 2025 Ioniq 5 has a new battery. It is 84 kilowatt hours now instead of the old 77.4 kilowatt hour battery. It's rated for 318 miles in the longest range trim, which is an extra 15 miles over the previous outgoing one. Here we have the Ioniq 5 SEL, which is the mid trim. It's running on 19-inch wheels, and it's got the Kumo Crugin HP71 EV tires, so EV specific, and surprisingly not super terrible in the snow, but those are the OEM tires. This new battery also has different charging from the previous one. It has a higher peak, about 260 kilowatts. However, it's overall a little bit slower. They now claim a 10 to 80% in 20 minutes, where it used to be 18 minutes. Regardless, that's still very fast and pretty much class leading. This Ioniq 5 all-wheel drive SEL on the 19s gets 290 miles range on the EPA cycle, and that's a combined cycle, so it's not only highway driving. However, we have been using that as a reference, and some cars are able to make it, some cars are not able to reach it. I think today it will be pretty tough for this Ioniq 5 to reach 290 miles. Fortunately, we don't have any wind. We just had a major windstorm, 55 plus mile per hour winds on our route, but it cleared up today, just this morning. So fortunately, no wind, and it is a little bit chilly. We're gonna be in the 40-degree range. So temperature does negatively affect our results on as far as range goes. Battery chemistry is affected. Basically, there's more internal resistance. Chemical reactions are slower. It's just less efficient. And additionally, with colder weather, you also have more dense air. So the car has to work harder to go through denser air. So not ideal conditions. However, those are the conditions we have, and it's Colorado winter. We're testing in the real world, so it is what it is. And I think it'll be a really interesting data point to see exactly where this lands, because we haven't tested an Ioniq 5 in quite a long time. Now let's talk about procedures. Of course, the first thing that I did was set the tires to the factory recommended pressures. This is important because it can affect your rolling resistance, and set those all earlier, and they are all set to 38, which is what is recommended. The next thing I do is I drive over here to Wellington, Colorado, plug in, and charge up to 100% state of charge on this DC fast charger. This does a couple things. First, it makes sure that we're at 100% state of charge when we leave, and also it heats up the battery. And this is actually something that's kind of helpful because a lot of vehicles do have heat scavenging. Heat scavenging is essentially taking heat from the battery and using that elsewhere. So maybe the cabin is cold, but the battery's hot. It can shuffle that heat around and heat up the cabin a little bit. That can help with efficiency, and we're gonna see if it'll be helpful here today as well. Additionally, with that hot battery pack, we don't have a cold battery, which is worse for efficiency. So a nice little benefit for all the cars, and this is a standard procedure that we do for everything. While it's charging up, I'm actually going to head into the car and make sure I turn it on before we leave, and I'll have the cabin set between 68 and 72 degrees in auto in the most efficient setting possible. And this will be to make sure that the cabin is nice and warm, heated up using power from the charger rather than power from the battery. This is, again, giving the best opportunity for the vehicle to get as much range as possible, and the same thing that we do for every vehicle. From there, I'm going to unplug and put the vehicle in its most efficient drive mode setting. It's Eco in this car. Make sure the climate control is set between 68, 72, not using any other auxiliary heating or cooling. So like a heated steering wheel, heated seats, not using those. But we're just gonna go off and head onto the highway, which is right there. It'll be a nice, gentle acceleration up to 70 miles per hour GPS speed, and GPS speed actually matches our indicated speed, so that's really nice for us. So we'll be doing a slow acceleration up to 70 miles an hour and setting cruise control. Once I'm at about 60-ish% state of charge, I'm gonna go ahead and turn around and head back here. I am not going to set these chargers as a destination, and the car will not precondition itself. That does use a little bit of extra battery and will negatively affect the range number. So once I get back here, I'm going to make sure that I have enough charge and basically do laps around the highway and see how far I can go maintaining 70 miles an hour. And throughout this time, I'll just be keeping an eye on the state of charge, keeping you updated on everything. And once I get to a low state of charge and I don't think I can make it too much further, I'm going to head off the highway and go to a frontage road, which is right next to the highway, and run it out of battery there. Once the vehicle can no longer maintain 70 miles an hour, that's when we say the results are in. That's our result for the 70 mile per hour range test. However, we're not totally done because we've got a pretty cool opportunity. The car is at super low state of charge, and we think it's interesting to know what happens when it's running out of battery and what happens when you completely die. So that's exactly what we'll be doing. And we'll just run the car out, run it for as far as it can go until it can no longer move. And then we'll show you what happens, explain what's going on, and you'll get to see what that's like. I previously ran a 10% challenge with the action camera, and it was a different angle where you could only see the screen right here, basically. I have a new angle right here, which should be able to see the screen and the road a little bit. I am hopeful, and it looks like you should be able to read what's on the screen, but I will also read everything out to you. But regardless, I'm interested to hear what you guys have to say, if you think that this is going to be a good angle, good solution, or if you have any other suggestions. Okay, 100% state of charge right there. Just clicked off. I'll unplug and we can get on the road. Okay, I've got the climate control set to 69, nice. Auto, lowest setting. Drive mode, eco. And I think we're set. Turning on to I-25 North. Doing a nice gentle acceleration up to 70 miles per hour indicated. Not sure if you can see the speedo or not, but that'll be where I'm headed to. And the goal is to reach 70 miles an hour at the end of the merge lane, so right up there. 70. We've only gone 18.5 miles, and we're doing 2.3 miles per kilowatt hour, which is pretty poor. Joining as I move from I-25 North to I-80 East. Right now we are at 86% state of charge. We've gone 29 miles and have an efficiency of 2.5 miles per kilowatt hour. We do have a truck up here, but otherwise things have been smooth. I did want to mention one of the, or actually a couple new things with this new 2025 Ioniq 5. And the first thing is new infotainment. And it seems pretty solid. There's a lot of cool features and a cool breakdown of how energy is being used. Still fully trying to figure all of it out, how it works and how to interpret it best. But it looks pretty cool and it could be a pretty interesting tool to use. The second thing is a row of buttons right here, which I don't know if you can see, but it is below the center screen, and it is a row of hard physical buttons. And there's also buttons in the center control stack, and it has a lot of the important stuff that you would typically want to use all the time. So like map, audio stuff. It has a volume knob. Geez, it's crazy that I have to point that out. But a volume knob, it's got heated seats, heated steering wheel, all of these things are physical buttons, which is, in my opinion, pretty nice. The only thing that I wish was a physical button was temperature changing. That is part of this screen down here. All the HVAC is part of this little screen. It's not like a LCD or OLED or anything like that. It's just like a little basic light up capacitive screen. 75 state of charge now. We have gone 64.3 miles, and we're doing 3 miles per kilowatt hour. So a little bit better on the efficiency side, and it's looking like we'll probably get close to 250-ish miles as long as we have a linear discharge curve. So hopefully, and how it should be is every 25% should have a similar amount of range used, but that's not always the case. Welcome to Nebraska. Just a quick update, only 72 miles in. Its temperature has been between like 36 and 40 degrees, so pretty warm. Not sure if you can see it. Sorry, not pretty warm. That is pretty chilly. I wanted to do one extra clip showing this EV range history where it shows that straight line that's diagonal down is showing what it projected, and then the bolder white line is what actually happened. So you can see that it started out, we did better, and then toward the end, at the very end, we did worse efficiency than expected. So it actually looks like we're pretty close to what the projection was. Interesting. You joined me at 50% state of charge right when I said I was going to be turning around, and it worked out that there's an exit right here. So this works out well. We're turning around at Dick's. That is the name of where we're turning around, I promise. We have just crossed 100 miles right now. 3 miles per kilowatt hour. And now I can just take it off cruise control and do a nice gentle deceleration. Now I've got regenerative braking on, and I put it onto level 3, and that is the maximum level before it gets to iPedal. iPedal will force both motors to be working, whereas with eco mode we can have some clutch disconnect. It will make it a little bit of a difference on the highway, I think. So this is the most efficient setting, and just doing regen braking, putting as much energy into the pack as possible. Here's the entrance. Going west. Now going back. And then one more slow acceleration up to 70. We've reached 50% state of charge, and we've gone 121 miles is what it says. It was 121 when it turned over. 2.9 miles per kilowatt hour, which tells me that we're a little bit less efficient on the way back, which is totally fine. And we're on track to do about 240, just over 240 miles. So a little bit less than that initial estimate that we thought at the first 25%, but not too far off. Earlier today, we had a windstorm, and I think that this right here is actually a result of it. Now, I do want to clarify, there is almost zero wind right now. However, this is a tipped semi. So yeah, 55 plus mile per hour crosswinds earlier this morning, but rain went away, so we're all set. Fortunately, doesn't look too bad.
Shoot, I was really liking the microphone. It sounded really nice, but unfortunately it cut out for the last few clips here. This is a 25% state of charge check-in. I'm at 170 miles, 2.8 miles per kilowatt hour. This is a little bit worse than the previous 25%, and we're now on track for around 225 miles. If you take a look here, you can see the low EV battery warning. This occurs at 10% state of charge. I've gone 203 miles, and at this point, efficiency is up to 2.9 miles per kilowatt hour. Honestly, not too great, even given the near freezing temperatures, but let's see how it finishes. At 5% state of charge, we get a warning. Charge immediately, power limited. It also tells us to go find a charger on the center screen. At this point, I'm at 213 miles and back down to 2.8 miles per kilowatt hour. I'm now exiting the highway for the last time. I looped around once and I'm now at 3% state of charge with 220 miles driven at 2.9 miles per kilowatt hour. Of course, I'm still using regenerative brakes to slow myself down, giving myself a little bit more energy. It's a quick turnaround and I'm back onto the frontage road. Projected range is now 0 miles. I've done 224 miles, so let's see how big this bottom buffer really is. Slowing down here, I actually reached the end of the frontage road. It's about a 6-mile frontage road. I wasn't really expecting to get this far. It's just a quick turnaround and I'm accelerating back up to 70 miles an hour. Here's a quick flyby of the rescue truck. Okay, this is foot to the floor. We're doing as much as the car can do, and I can't get to 70 miles an hour. We're gonna call it here. We made it 231 miles before the car could no longer maintain 70 miles an hour. We had an efficiency of 2.9 miles per kilowatt hour. We also went an extra 7 miles at 70 miles an hour after reaching 0 miles of range. It's gotta be more than 2 kilowatt hours of usable buffer. Turning around for what should be the very last time. Foot to the floor. Oh wow, the acceleration is incredibly slow, but believe me, I will make it all the way up to 40 miles an hour eventually. Okay, 3 miles later and we're finally running out. I actually have a power meter up on the center screen, but of course you can't quite see it. It tells us that we're pulling between 1 and 4 kilowatts. We're barely creeping forward. There's a little bit of a downhill right here, so I'm going to take this opportunity and use the momentum that I do have to make sure I can pull all the way off the road safely. I really don't want to block the entire lane. I managed to go a total of 235 miles, an extra 11 miles below zero. But here's where things went south. The Cybertruck was there to rescue me, and it had a Tesla mobile connector, and that's because the new Ioniq 5 has a Tesla charging port, the J3400 port. Unfortunately, it wouldn't charge. We could get power to the Tesla mobile charger no problem. It was showing green, but as soon as we plugged it into the Hyundai, it went red on the T, so it just would not charge. We went looking for a J1772 mobile charger, and the only thing we could find was a level 1 charger. Unfortunately, that one was only pulling 8 amps, and it would have taken hours for us to charge back up just to make it back to the charger. So I did something I've never done before on one of these tests. I don't plan to do it again, but I got towed. We did make it to the charger safely, but I definitely want to avoid that in the future, so on our future tests, we're going to be carrying both a J1772 and a Tesla mobile connector. Make sure that we're covered on all of our bases.
But with that, let's go take a look at some results.
231 miles was our final result. This is right in the middle of the pack when it comes to crossovers. I suppose you could call this a win, considering the temperatures were quite low, lower than most other tests. Still, a 2022 Hyundai Ioniq 5 managed 227 miles. It was a tiny bit warmer for that test, but still, it's a really close result. I'm not fully convinced that there will be much of a difference between the range of the old and new Hyundai Ioniq 5s. That's a head-to-head comparison I'm excited to see. Still, it's hard to get away from the middling performance. Yeah, it's better than some of the stuff like old Polestars, Volvos, and Toyota BZ4X. It's still short of many vehicles, including stuff like the Chevy Bolt EUV, Nissan Ariya, Volkswagen ID4, none of which are known for having great range. It's really just kind of a meh result. Next, efficiency. 2.9 miles per kilowatt hour. Yes, it was cold. This is also a pretty poor result for a crossover. This is on par with some pretty spicy performance crossovers like the Mercedes-AMG EQE SUV, Polestar 2 Performance, and EV6 GT. None of those cars were meant to be particularly efficient. The new Ioniq 5 was just as bad, yet nowhere near as spicy of a vehicle. It's warm at most. It's not a performance crossover. That's the Ioniq 5N. And for reference, the 5N only got 2.7 miles per kilowatt under fair conditions. So it seems like the Ioniq 5 is consistently showing relatively poor efficiency and performance. To be fair, the 2022 Ioniq 5 managed 3.1 miles per kilowatt hour, which is pretty okay for a crossover, but still on the lower end of the group. I find this pretty interesting because the EV6 has done relatively well in comparison. The old EV6 GT was tested next to a new Ioniq 5N and got 2.9 miles per kilowatt hour compared to the 2.7 in the Ioniq. We tested an all-wheel drive EV6 as well. Conditions were warmer and it managed 3.4 miles per kilowatt hour. That's a pretty darn good efficiency for a crossover here. I find it interesting that it seems like this EV6 is outperforming the Ioniq 5 when it comes to efficiency. We already saw that on the head-to-head test between the new Ioniq 5N and old EV6 GT, but now we're starting to see that a little bit with the other trims, though we do always have to be really careful here comparing results because they are under different conditions. Still, it does seem like it's trending towards showing that EV6 is measurably more efficient. I'm excited to get more EGMP vehicles in to investigate this further, and hopefully we'll have some of those head tests very soon. I do have to say I came into this test with relatively high expectations. I really love EGMP vehicles, and their charging is incredible, class leading. I did not expect it to go the full EPA estimate 290 miles, given the cold temperatures, but I did expect a good bit more than 231 miles. Still, it's not a terrible result. It's right in the middle of the pack when you compare it with other crossovers. It's really totally usable. Well, that's all I have for you today. Thank you all so much for watching, and I'll see you all in the next one.